All right. I guess in that case, let's invite all the authors back so that we can do a quick panel discussion. If there are questions from the audience that you didn't get a chance to ask during their talk, now is the chance. So we can do about 4 or 5 minutes. Okay. Anyone have any questions? Okay, seems that there is no immediate question from the audience. I guess I can try to ask something that is common across the different papers. I think there are papers on different things, but I guess there's one common theme is there is this processing either on edge devices or centralized in larger data centers. So what are you guys' opinion on, so in the future, what should we do? Should we do it on the edge or should we push it to some centralized location for this processing, either for efficiency reasons or privacy reasons? What's the good solution here?
I can say something, but I'm the efficiency things. I mean, I think that having a mix of both is good. I mean, our approach is that you kind of want to optimize, take advantage of the centralized resources when you can. So we try to offload a lot of the super intensive computational stuff to a centralized source. But I do think that with how powerful our devices are becoming, I think it is good to utilize devices for privacy. And also I think that devices can help doing certain things such as enforcing accountability and transparency in terms of auditing how the system works. And so I'd like to see more innovation around that, of how can our devices actually be making sure that what we think is happening is actually happening, and having like that actually happening on devices is cool. So that's my perspective working in privacy, but I'm not the most, real graph systems expert, which these guys are. So
yeah.
Thank you.
Yeah. In my opinion, I think the privacy is a big problem. But I have little experience working on the privacy, so I will talk from the aspect of the efficiency. In my opinion, recent days, people are finding that the graph computing are more bound on the memory access or the communication, because a graph is more like data access intensive applications than the CPU computation or GPU computation intensive application. So the network speed or the memory access speed is very important. So the edge computing may, in the efficiency aspect, may be very slow. And even in this centralized cluster, people are nowadays tending to only use one very powerful machine with hundreds of cores and more than 1 terabyte memory, so that they can completely avoid the overhead of graph partitioning or avoid the communication, the overhead of communication, and that is one of the trend. Yeah.
Right. Thanks, Ke. So, Silver, do you have any comments on the IoT space?
Since my colleagues answer from privacy and efficiency point of view, I'll try to answer this from an operational point of view. I'd imagine, to your question, the future applications, they should really be built not only cloud native or edge native, they should really be built sort of cloud and edge. You can sort of migrate applications from one place to the other, cross region, cross cloud regions or edge region, or also on-prem freely, and based on their privacy demands, efficiency demand, latency, and other performance demands. And for DSpace in particular, we built our system, we implement our system on top of Kubernetes. And this allows us to say you have this digigraph with different digivice and digidata. You can choose where to run these digivices. For example, you have a privacy sensitive, like a video processing digidata, and you want to save the upstream bandwidth, you're probably going to need to run that on-prem in your home with some devices. And then if you have some device that's going to use cloud services, you probably co-locate it with your cloud services. So we enable such flexibility, and we envision other systems, our distributed system, they should also, in one way or another, support such flexibility. And this will make the, people talk about IT and OT, this will make the operational side of things much simpler. So the location agnostic. Great question, thanks.
Awesome, awesome. Thank you all for your insightful opinions. And so before we end the session, any other last minute question? We have 3 minutes from the audience.
A further question from Galway. Yeah, I just three presents discussed about privacy and efficiency, and I want to know, is it possible to let users have a knob to control the privacy and the efficiency? Because in different countries, they have different laws about the privacy, and so if is it possible to build a universal system to let users tune this parameter, tune the efficiency and privacy and something else? It's my question.
I guess I can go first, since I was mentioning this sort of flexibility between. So the particular knobs in this space that allow you to control this privacy or efficiency trade-off is where you can deploy these devices, right? You choose to deploy it on your home, that trade-off, like you're going to have some server at home to run this device, versus you run it at the cloud, you pay some cloud cost, but you sort of lose your privacy. So it is this deployment API that's allowed you to users to make this choice. That's from my part.
Thank you.
I'm not familiar with this area, but I have a very intuitive opinion, maybe naive, but I don't know if it is possible that one can upload the data, and before the uploading, the data is going to be processed so that its private information is hidden or eliminated, and only the information we needed will be uploaded to the centralized cluster, and that place. So all this already anonymous data can be processed very efficient. I don't know if this is possible.
So maybe I can add something that it's less about necessarily choosing a privacy. There are some, just speaking about differential privacy, there's some architectures in differential privacy which let you do local noise addition. So for instance, every one individual is adding a little bit of randomness to their own data, and then you kind of don't need as much protection because every data point is more private because each individual has some sort of protection. And there's also some architectures that do some sort of shuffling, which breaks the anonymity link between whoever's sending the data and then whoever's receiving it. So these have some natural trade-offs of privacy and accuracy. It's less so about each individual making that decision though. So I think there's less work on that like short-term flexibility on giving each person an ability to decide. And I think we don't really understand still yet what it would mean for people to decide about privacy. It's kind of, in some, I mean, it is a social term as well as, even though we have technical definitions for it, we still don't have yet good notions for what it would mean to have a truly flexible privacy decision. Yeah.
All right. Okay. So unfortunately, our time is up. Let's thank our authors again. And thank you all for your great questions. We will now start the next session. Unfortunately, we took more time than we are supposed to. Thank you all. Okay. But you can keep the discussions running on Slack. And go. You can either use the sessions channel, or you can just find individual authors to ask your questions. It's a great discussion. Thank you.
Thank you.
Yes.
Bye.
Bye-bye.
Bye.